Lesson 10.1 Sequences. A sequence is a list of numbers following a rule, such as 3, 6, 9, 12. Keep adding 3 would be the rule. This one is finite because it ends. 0, 3, 6, 9, 12, comma, dot, dot, dot. The dot, dot, dot means it's infinite, doesn't it? It continues forever in that same pattern. These are kind of like functions. The n is 1, 2, 3, 4, 5, etc. It's the term number. So it's like the 0 was the first term, the 3 was the second, the 6 was the third, the 9 was the fourth, the 12 was the fifth. So those are the n's, or which position it is. It's like the x. And then the an is the value. So the first term is 0, the second term is 3, the third term is 6. So A4, the fourth term is 9, and that's like the y. So use n and an instead of x and y for sequences. That's because in a sequence, there's no numbers between the 1 and the 2, like there is in regular. So these are called discrete maths. There's no fractions in the inputs. Our example, find the first 5 terms of the sequence. And we're going to do that by plugging in different numbers for n. For example, A1 would be when we plug in a 1 for the n. So it would be 5 plus -2 would be 3. A2, plug in a 2 for the n. So the -1 squared becomes +1. We'll end up with 5 plus 4, which is 9. Plug in a 3 for the n. 5 plus 2 times 3. -1 to the 3. Okay, because the exponent on the -1 is odd, it'll be a -1, and we'll have 5 plus a -6, just -1. A4, plug in a 4 for the n. -1 to the fourth is +1, so we'll have 5 plus 8, which is 13. And lastly, the fifth term, plug in a 5 for the n. -1 to the fifth is -1, so a 5 plus a -10 be -5. All right, this time let's go the other direction. Write the rule for the nth term. Well, here we need to just kind of try to find a pattern. So these are the a-n's. Remember, the n's are 1, 2, 3, 4, 5. And so we can look at this and we can see, well, the pattern seems to be adding 4. So we have a +4, a +4, a +4, a +4. So to get to the 17, it'd be something plus 4 4s. Okay, so it'd be the 1 plus 4 4s. To get to 13 would be 1 plus 3 4s. So it looks like we're going to be something like 1 plus some number times 4. But what number is that? Well, the 13 we added 3 4s, and the 13 is the fourth terms, and the 9 would add 2 4s, the 17 would add 4 4s. So it looks like we're adding 1 4 less than what we have for the n. So we'll call that n minus 1. So we started at the 1, and then we're added some number of 4s, and the number of 4s is 1 less than whatever the n value is. Then we can just simplify. So it looks like it'll be 4n minus 3. Let's try another one. All right, this one's interesting. It switches sign back and forth. The switching of sign back and forth means we're going to have -1 either to the n or the n plus 1. if I have it to the n, when n is 1, then it would be negative. But if I look, when n is 1, it's positive. So I'll go n plus 1. Therefore, when n is 1, it would be negative 1 squared, which is positive. When n is 2, it would be cubed. Negative 1 to the third is negative, which fits our second spot. So we want that. And then our pattern. What is our pattern? Well, notice these are 1 plus 1. If I ignore the negatives, this is 8 plus 1, and 27 plus 1, and 64 plus 1, and 125 plus 1. So what's that? Well, the 1, 8, 27, 64, and 125, those are perfect cubes. So that's a perfect cube plus 1. So it's n cubed plus 1 times the negative 1 to the n plus 1, which makes it go back and forth between positive and negative. We also have something called recursive rules. Recursive rule is we use the value of one term to find the next term. In this, we're going to say an is the current term and an plus 1 is the next term. And so a recursive rule could look something like this. You're always told the first term. You have to know where you're starting. And then you can fill it in to get the next term. So the first 5 terms, well, they told us the first one. And then to get A2 would be putting a 1 for the n. So that would be A1 plus 1. Oh, wait, A1 was 6. So A2 was 7. If I put in a 2 now for the n, it would be A2 plus 1. Wait, A2 was 7. 7 plus 1 is 8. A4 would be putting a 3 for the n. So I get A3 plus 1. A3 was 8. Oh, hey, look at our pattern. We're taking the number we had before plus 1. So 6 plus 1 is 7. 7 plus 1 is 8. 8 plus 1 is 9. Following that pattern, A5 would be 9 plus 1, which is 10. The other thing we're going to look at are factorials, which use an exclamation mark. A factorial is the product of a whole number with all the whole numbers less than it through 1. For example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. And by definition, 0 factorial equals 1. So let's simplify this. Well, let's see. 9 factorial will be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Notice all the numbers 7 and down cancel out. So it looks like I have 9 times 8, which is 72, over 3 times 2 times 1, which is 6. 72 divided by 6 is 12. Yes, there is a factorial button on your calculator. It would be in your math menu. You have to go sideways to the probability menu and down until you see the factorial button. So let's try something more interesting. Let's simplify it with variables. So n plus 1 factorial could be, well, it's n plus 1 times the next number smaller than that. Well, the next number smaller than n plus 1 is n. And then n minus 1. And then n minus 2. Then n minus 3 and n minus 4 and so on. N factorial will be n times the next number smaller than it, which would be n minus 1. Then the next number smaller than that, and so on. You can see that cancels and we're left with n plus 1. That's it for today. Have a good day.